Hi everyone. We're now going to talk about functions that return functions. Now, this might sound a little bit like some sort of inception type thing, but it's really not that complicated. All that we're doing is defining a function inside of the outer function and then returning that inner function, but the inner function has some variables that were defined in the outer function. So let's see what I actually mean. So let's say that we want to define a function which returns. It takes in a function f and then gives us back a function g, which is the derivative of f. Now, as we might have learned in high school math, the derivative of a function is if I take some very small value and I call f of x plus that small value, subtract f of x, and divide by that small value. So we define g to essentially say, okay, g also takes in x, just like f did, except g returns f of x plus h and f of x, subtracting that, divided by h. So essentially, let's say I say define f of x, return x squared. So if I called the derivative function on derivative function returns another function g. So I'm going to say f prime is equal to derivative function of f. This returns to me another function. However, that function was basically constructed to be the case that now it uses this specific f. So I passed in f, and so this g of x uses f of x equals x squared. So now f prime is specific to x squared. Let's say that I do a new f, def, I'll call it h of x, return x cubed, and I say h prime is equal to derivative function of h. Now this is going to construct a different g, which now inside of that g, the f right here is referring to h of x. So in this way, we can basically use the idea of closures, except now it's doing a closure with a function, and it's going to create a new function which is specialized for the function we passed in. So if we look at the examples provided, we say f of x is equal to all of this, 5x cubed plus 10. I call the derivative, and so I get f prime 1. I call the derivative of an f prime 1, and I get f prime 2. So f of 3 is equal to 145. F prime of 3, so the derivative of 5x cubed plus 10 is 50x squared. So 9 times 50, 3 times 5 is 15, so it's 15x squared. So x squared is 9, 15 times 9 is 90, so we should get about 90. And then the derivative of 15x squared is 30x. So 3 times 30 is 90. So when we run this, we see that we get 145, that's the f, 135, which is f prime, and then 90, which is the second derivative of f.